Assalamu alaikum class. Hope you all are fine. I'm your computer teacher. Yesterday we were discussing about the chapter that was data representation. Our today's topic is related to how can we convert a denary number to a hexadecimal number, right? In our previous lesson, we discussed about the whole hexadecimal system, that its base is 16. Digits includes from 0 to 9, and it includes letters as well, like A, B, C, D, E, F. They are having the decimal values like A is having a decimal value 10, B is having 11, C 12, D 13, E 14, F is for 15. These are the examples of hexadecimal numbers like 2F, FA, and so on. Okay. Okay, students, kindly open your books. Page number 10. Here is the topic like converting from hexadecimal to denary and from denary to hexadecimal number. In previous lesson, we discussed about how can we convert a hexadecimal number to a denary number. Our today's topic is related to how can we convert a denary number to a hexadecimal number. Page number 11, there is the procedure we are going to discuss in the class, right? Here is an example that we are having denary number 846 is a denary number to a hexadecimal number, right? Okay, for your ease, as we use base 16 in hexadecimal number, I have written the multiples of 16. You have to use it while converting a denary number to a hexadecimal number. Right? It is the same procedure that you have done in mathematics. You have to use the LCM. But in this LCM method, you always have to use 16 as a base. Right? Okay. 8463. Right? It is a denary number. First step is you have to divide it and use the remainder. Divide it and get the remainders. Always start with the base 16. Every time you are dividing any digit, you have to use base as 16, right? Same as in the mathematics, you divide like 8463 divided by 16. You will use these multiples of 16. First, what you have to use is 8 how many times? 16 how many times? 16 5 times is 80. We will get 46, right? 16 how many times? Less than 46. That is 2 times. 2 times 32, right? After that, we will get like 143. And it will be how many times? 28, and here to get the denary value, right? Okay, like in our binary number system, we have used remainders like denary number to a binary number. In the same way, we have to divide it and you have to use the remainders. We got 528 and the remainder is 15, right? In the same way, you have to use 16 as a base. Same as the previous step, we have to divide 528 by 16. Okay. How many times we will use? We'll use 3 times 16. 3 times is 48, right? And we will get 48 and 16. 3 times 48, and the remainder is, we are having no remainder or 0. No remainder means it is 0. 16, 30, 3 times 528, and the remainder is 0. Right? In the same way, we will divide it again. 16 times 16, how many times? 16, 2 times. 16, 2 times, we got 32, and the remainder is 1. Then, again with the 16, at this step, students, just focus on this step. What we have to do is 16 divided by 2. Is it possible? Yes. How? 16, 0 times is 0, right? 16, 0 times is 0, and we got the remainder 2. 2 is the remainder. We can say that 16, 0 times 0, and we got the same remainder like 2. Clear? As in the binary number system, we wrote the answer from bottom to top. Yes? In binary number system, you have done the binary number system now. You always write the answer from bottom to top. Same in this case, you have to write the answer from bottom to top. Like, it will be 2, 1, 0, and 15. As we have done in the hexadecimal system, whenever we are going to have a letter, we have to replace with the decimal value, and decimal value with the, when we are converting from denary to hexadecimal number system, we have to convert a denary number into a hexadecimal or letter number. Like 15 is can be represented with the F. So we can write it as, we can say that as F is for 15. So we can write it 2, 1, 0 and F. 2, 1, 0 and F is for 15. And it is the hexadecimal value. We can say that 8463 denary number is equals to 210F hexadecimal number. Right? The same question we have done in previous lesson. When we convert the same hexadecimal number into denary number, we will get the same answer. We are converting from denary to hexadecimal, then hexadecimal to a denary number, right? Okay, let's do another example. Okay, we are having like 2004. It is the denary number, same as in the previous case. 2004, always use base, that is 16. Then how many times? That is 125 times, and the remainder is 4. You know this step very well. like 2004 divided by 16. 16 one time 16, and that will be 4. 0 2 times, that is 32, and we get 8, 84, and 84 how many times? 5 times 80, and we got the remainder that is 4, right? Can you see it clearly? That is 4. Same with the next step. What we will do, we'll divide with the 16. 16 divided by 125. 16 divided by 125. We will get the answer like 7 times 16, 7 times 1, 1, 2, right? 5 minus 2, that is 3. 2 minus 1 is 1, and this is the remainder. 16, 7 times 112, and the remainder is 13. Same with the next step. We will divide the 7 by 16. 16, 0 times 0, and we get the remainder is 7. 7 is the remainder, right? It will be like 0, and the remainder will be 7. Same with this case. We'll start writing the answer from bottom to top. Like 7, 13. 13 can be placed with the letter. 13 is for D, D is for 13. 7, D, and 4. We can say that 2004 decimal value is equals to 7D4. It's a hexadecimal value. Clear, students? I hope you got this concept that you simply have to divide it, use the remainder, and after getting all the remainders, you just have to write the answer from bottom to top. If you are getting any value that is greater than 9, you have to replace that value with the letter, right? Is it clear? Is it clear to you? Okay. Let's discuss some example with the help of slides. Let me show you some slides. Okay. I hope you can clearly see all the slides. We are having chapter that is data representation. I told you all the steps that you have to do while converting from denary to hexadecimal number. Then we are having example like 126 is a decimal number. You have to simply do is divide it 7 times, and the remainder is 14. After that, 7 will be divided by 16, and you will get the remainder that is 7. So from bottom to top, you can write the answer 7, and 14 is for E. We will replace letter, and we got the answer 7E is a hexadecimal number. Same with the next example. We are having 603 decimal number or denary number. We have to convert it. Simply divide it, get all the remainders, and if you are having value greater than 9, you have to replace with the letter. Is it clear to you? Okay. Let me show you some other activity that is mentioned in your book, page number 1.6. I hope you can see it. Page number 12, activity 1.6. You can use all these questions for further practice. Okay, I will share a worksheet with you as well. You can solve it and send me back in the Google Classroom, right? If you are having confusion, just write in the comments that I am facing this kind of problem. Kindly elaborate me or solve it for me, right? It is all for today about Dendy 2 hexadecimal. Thank you so much. Have a good day. Allah Hafiz.